Hey, good day. Mike Mata here. Going to continue our journey through the hacking process and how to use Wireshark to build filters looking for signatures of the network reconnaissance. So we spoke in some previous videos about DNS zone transfers. We've also talked about this, evaluate the target. What's the hack value of the target? The first phase is reconnaissance. So again, if you look at some of the previous videos, we did the first one on domain name, where you can just basically perform a domain name transfer over port 53. We built a filter for that so we can find if there's a transfer that sent your domain information. Gathering the network block information, what are the IP addresses? I kind of did that with one of the previous video on network reconnaissance. And as part of that NMAP tool, then we can also gather TCP and UDP services that are running on the hosts. We can even gather some of the architecture info, like is it a Windows box, Linux box, etc. So let's take a look at that as well. In Wireshark, I've got a trace I used NMAP to come up with that information. So first off, let's show you NMAP. Again, NMAP, the Unix version, NMAP, the Windows version of NMAP, and basically I've done a quick scan of my local subnet, and we talked in the previous version that the ping scan basically on a local subnet does an ARP scan. Again, ICMP would be a normal ping, but since it's local here, we're just basically doing an ARP scan. So to see the quick scan, what it does under the hood in Wireshark, again, it comes up with, here's the IP addresses of my network. It finds what's the MAC address, what ports are open, if you think, TCP ports, the services that are running. And again, how does it do that? We're going to focus really on one of these and build a couple filters just to see that. So into Wireshark, again, you see it does the ARP. It ARPs up the entire subnet basically to find out what devices are listening and who does it get an answer from. So we'll walk through a few of those. We see who has 192.168.1.11 till 154. We get an answer from 192.168.1.10. That is at this particular MAC address. So we know we've got a live host. NMAP knows there's a live host there, and at some point it will start scanning for that .10. So the easy filter to find that, IP dot dest host equals 192.168. Well, we'll do .20 since I already had that one in there. So we're going to look at .20, but we should find that as well. Let's just go take a quick peek. Somewhere there should be a .20. There's 25, so 20 must have answered somewhere. There's 50, so I must have already passed it. It keeps going up. There's 45. So I did find one, .20. I just want to go verify that in our NMAP. Yep, we got it right there. NMAP scan for .20. It shows there are 3 services active, port 22, 80, and 443. So we'll just go validate that. When we apply our filter for the destination host of 192.168.1.20, we see it try to send sync requests for all kinds of different ports to see what applications are active and running. So we see it's trying to sync all kinds of ports, 53 DNS, 113, 3389, Microsoft, 554.21, FTP, 8080, just running through a big list of ports. Let's see what it responds back with. So let's look at the source. The source of 120. And so we see source of dot 20 replies back on port 445, not open, closed for business, reset, reset, reset. Ooh, but we do get a sync ACK on 443. So there was one of the ones listed. We get a sync ACK on 22, and we get a sync ACK on port 80. So there are the 3 different ports that are listed. We can easily see that by ANDing another rule. The TCP header starting at 13, offset 13. So I'm just going to TCP 13, looking for the hex value. Those of you that have the spreadsheet, you know why we're doing this. Equals equals, and we're going to do 0x of a 12. And I'll show you that here in just one second. That is also going to then look for sync ACKs, TCP sync ACKs right there. So we got the source host and the sync ACK. If we come down here into the TCP header, the flags, that's what we're looking for right there, is this hex 12. There's our filter starting from the TCP header 13 bytes in. That's looking for the ACK bit and the sync bit to be set. So what services are running? And so we see 443, 22, and 80. This is a wonderful filter. Also looking for, viruses, hosts that have viruses, malware. Think about your environment. Client machines should never reply back with the sync ACK. That servers should only answer with sync ACK. So if we're seeing client IP addresses with sync ACK, that's a very good indication that you have malware on that particular client machine. But in this case, we see NMAP, ZenMap, sent out all these requests, and it got 3 replies back, and it tried that, it looks like 4 times there. I guess it's the Valley Girl. It needs to be for sure. These probably have different options maybe in them. I haven't investigated any further. We do see they are different sequence numbers right away. That's, no, it's not. 854, 854, 854. So they're not different sequence numbers. It's using the same sequence number. So there may be different options in the TCP header. In this case, there are 4 options. We can go look at that quickly. In the next one, TCP header, also 4 options, max segment size. So it doesn't look like that's really changing. How about that one? 4 options, again, max segment size. So yeah, it looks like it's the same options. So it looks like it's just doing it 4 different times. But again, we now have a filter to see what happens when ZenMap is trying to footprint an IP address and what services are running. So you can very quickly now have a signature to find this kind of traffic going on in your environment and know that someone is scanning. If I look at ZenMap again here, if I look at ZenMap, we can see it found all the IP addresses, and again, as we go through, you see that it documents what ports are active and listening on those particular devices. And there's .50, there's the server, and so we can see there are all the different ports that are open on that particular server. So hope that was beneficial. Thanks for listening, and make it a great day.